All right, this is Honors Algebra 2 Pre-Calculus. We're doing 4.2, and this is our second video. Let's talk some about even and odd functions. So some of this is review, but we're also going to specifically apply this to trig functions. So what it means to be an even function is that if you plug in a negative x, you get the original function back out, meaning, so let's look at a classic example, which is x squared, right? So if I plug in a positive 2, right? If I plug in a positive 2, I get 4. But if I plug in a negative 2, I get the same 4, meaning that f of negative 2 is the same as f of 2. That's what it means to be an even function. Visually, it'll be symmetric about the y-axis, meaning you can fold across the y-axis. So trig functions that are even are secant and cosecant. Those are the only ones. Basically, they're the ones that only involve the x on the unit circle. What it means to be an odd function is if you plug a negative x in, you get the opposite of f of x out. So let's look at an example here, right? If I plug a 1 into x cubed, 1 cubed is 1. But if I plug a negative 1 into x cubed, I get a negative 1. I get the opposite of that original out. What an odd function looks like is that it's symmetric about the origin, meaning if you rotate it 180 degrees, you get exactly the same graph. So the other four trig functions, sine, tangent, cosecant, and cotangent, are all odd functions, okay? So knowledge of even and odd functions is just another tool in the toolkit that helps us evaluate trig functions by hand. You might not choose to do problems that we're going to walk through this way. That's fine. I don't know that I would either, but it's definitely an option, right? So let's go ahead and walk through some problems. So we can use the even odd identities to evaluate these trig functions. So because sine is odd, sine of negative 30 degrees is the same as negative sine of 30 degrees, right? Which on the unit circle is right here, and that would be a negative in front of a 1/2. And it is helpful to start to know your unit circle. I obviously know it better than some other people, right? And I'll show you another way to do A. So the other way to do A is to visually consider what a negative 30 degrees looks like. This is a positive 30 degrees, so negative 30 degrees is right here at the point root 3 over 2 comma negative 1/2. So you could have just figured out that the sign of negative 30 would be this negative 1/2, and that's also totally fine. So secant of 120, well, because secant's an even function, if you, of negative 120, because secant's an even function, if you plug in a negative 120, you just get the same as secant of 120. So you have to think, where is 120, right? What's the value at 120? Well, 120 has a cosine of negative 1/2, right? So this is going to be the flipped version of the cosine. It's going to be a negative 2, right? Tangent of negative 135. Well, tangent's an odd function, so I'm going to get negative tangent of 135, right? If we look at where 135 is, right, that's right here, and it's a 45, 45, 90 angle, so that's going to both be root 2 over 2's. The trick is that because I'm in quadrant 2, the x will be negative and the y will be positive. Well, that's a value over itself. So this is a negative of a root 2 over 2 over a negative root 2 over 2. These two are the same value, but with a negative. So I end up with a negative 1 times a negative. So negative times negative 1, which is just a positive 1. All right. Okay, so same thing here. Cosine is an even function. Remember, cosine and secant are the only two even functions. So this will be cosine of regular 90 degrees, right? Well, if we look at where 90 degrees is, that's right here, right? So cosine of regular 90 degrees is going to be 0, because this is 0, 1, right? That's the point. Cotangent of negative 30, cotangent's a negative cotangent of regular 30 because it's an odd function, right? So when we look at 30, right, here's 30. Cotangent is going to be the x on top of the y. Well, the x would be a root 3 over 2, and the y would be a 1/2. So I end up getting that this is a root 3 over 2 times 2 over 1, or just a root 3 with that negative sitting in front. And I almost missed it, right? I had it here, and then I forgot to put it there and here. So it's a negative root 3. And then lastly, cosecant of negative 45, well, that's another odd function, so that'll be negative cosecant of 45 degrees, right? Well, 45 is right here, right? That's a root 2 over 2. So I'm going to get a negative of a 2 over root 2, because it's the flipped version, right? Because these were both root 2 over 2, and I'm flipping the y. So when I rationalize, I'm going to get that this is a negative 2 root 2 over a 2, or just a negative root 2. And that's my answer. Now, again, there are other ways to picture that. You could have, instead of looking at this spot, you could have said, hey, this is negative 45, and you could have just considered that angle instead. All right. So entering trig functions in your calculator, the first thing is you need to be in the right mode. So if you press the mode button, there's a radian and there's a degree. Now, right now, I'm in degree mode because I was doing the end of your, some of the end of this stuff for Chapter 4, and we do some word problems that involve degrees, but usually you're going to be in radian mode. So in calculus, we're going to be in radian mode most of the time, right? In this class, it's about 50-50 because we definitely do some word problems that involve degrees, right? So basically, you're going to have to gauge what's happening in the problem. If you're doing a problem where they talk about 60-degree angles, then you should be in degree mode. If you're doing a problem that doesn't give you measurements for the angles, then it's radians, right? Once we're in the right mode, right? So sine, cosine, and tangent all have buttons. So you can see them right here, sine, cosine, and tangent, right? So for instance, sine of pi over 6, if I'm in radian mode, is 1/2, right? Cosine of pi over 6 would be a root 3 over 2, and you could type that in your calculator and you'd get that value, right? Tangent of pi over 6 should be a sine over a cosine, so it should be a root 3 over 3, and if you type that in your calculator, that's what you'd get, right? So there's a sine, cosine, and tangent button. The biggest thing is you just have to be in the correct mode. Now, cosecant and secant and cotangent do not have buttons, right? They are not the button that's above the functions, right? So see there's a sine inverse and a cosine inverse and a tangent inverse. These are called inverse trig functions. And they're something we're going to talk about in 4.7. They do not mean 1 over, okay? They mean that -1 in them is sort of like you've seen when we did inverse functions and we did f inverse, right? So this -1 is like f inverse of x. It's not, right? It's not the 1 over. So in order to type cosecant, secant, and cotangent, you either have to do 1 divided by the value, so like 1 divided by the sign, or the other way to do it is to use this inverse button. Let me just highlight this for you right here. This inverse button right here, right? So the other way to do it is that you could type out, hang on. You could type sine of pi over 6, whole thing in parentheses, and then use this inverse button, because that would mean 1 over sine of pi over 6. Now, I personally prefer to do this. I prefer to do the division because then I don't accidentally make that mistake. But again, to be clear, you cannot use the sine inverse button. That means something else, okay? That's something we'll get to in 4.7, but it means something else. So if I wanted to put the cosecant of pi over 6 in my calculator, the way I would have to do it is I would have to do 1 divided by sine of pi over 6, right? And there's my answer, right? And there's the 2. All right, so we're going to go ahead and walk through a quick example and a practice problem, right? So now that we've learned how to do the stuff in the calculator, we're going to do something that doesn't involve the calculator. What we're going to do is, given the angle, we're going to find the 6 trig function value. So this is not on the unit circle, right? This is not on the unit circle. But it doesn't matter that it's not on the unit circle because all I need are the x and the y coordinates, right? So the sine of theta is going to be the y coordinate, which in this case is -3/5, right? The cosine is going to be the x coordinate, which in this case is -4/5. And the tangent is going to be the y, -3/5, on top of the x, which is -4/5. If we clean that up, that's a -3/5 times a -5/4, or a 3/4, right? Once I know those 3, I can find the other 3 by just flipping them. So it makes more sense to do all of the work on the front end with those. The cosecant of theta is just going to be a -5/3. The secant of theta is just going to be a -5/4. And I ran out of room a little bit, but the cotangent of theta is going to be a 4/3. So again, it doesn't matter that it's not on the unit circle. I have this point. That's the point I would need. All right. And I should clarify. It would be relevant if the I should clarify that. I know from my own knowledge that this is also a 1, right? And so I should clarify that it matters that it's the hypotenuse is actually a 1, but I know that this hypotenuse is a 1 because if we look at right triangles, right? So this was a -4/5 and this is a -3/5. This is a 3, 4, 5 right triangle. This is a 5/5, right? 3, 4, 5 right triangle. So, or you could use Pythagorean theorem, but here I know that the hypotenuse is a 1. So it's not on the unit circle we memorize, right? This isn't on the unit circle we memorize, but the radius is 1 unit. So that's the reason we're still able to do this, is just the y and the x. So to go to the next one, again, same situation. This is a 3, 4, 5 right triangle. 5/13 and 12/13. This would be 13/13, right? Because it's a 5, 12, 13 right triangle. So yet again, this radius is 1, and that's relevant because that's the only reason we don't have to pay attention to the hypotenuse. So again, the sine, right, the cosine, and the tangent. And then I'm going to flip the 3 of those to find the cosecant, the secant, and the cotangent. And me personally, I remember that sine and cosecant go together because the letters don't match, right? Notice that nobody's partner has the same letter, so it's not sine with secant, it's sine with cosecant. All right, so the sine is the y value, 5/13. The cosine is the x value, 12/13. And the tangent is the y on top of the x, so 5/13 over 12/13, which is going to end up being a 5 over 12 when you flip the 12/13, right? So 5 over 12. The flipped versions then will be a 13/5, a 13/12, and a 12/5. All right, and that's it for this video.